everyone, and welcome. My name is Cardano, and I'll be your lecturer today. In this unit, we explore encryption methods, a major part of cryptography. This lecture will introduce some technical concepts and terminology. Feel free to pause at any point and review. Let's start with terms. Cryptography is the science, encryption is the method. Encryption is the process of encoding understandable text into something you can't understand. Technically, encryption is encoding clear text, what you understand, into ciphertext. The reverse process, transforming ciphertext into clear text, is decryption. Let's now look at this diagram. The diagram shows an encrypted communication system. Alice wants to send Bob a message, but she doesn't want anyone, like untrusted third parties or adversaries, to read it. Alice encrypts the clear text and sends the generated ciphertext over the communication channel to Bob. Bob receives the ciphertext, decrypts it into clear text, and then reads it. Alice and Bob took several steps to ensure their conversation was private. The first step involved encrypting their data. To do this, they needed an encryption algorithm, which converted their original message into secret and uninterpretable ciphertext. This ciphertext looked like a series of random numbers and letters, like this. To use the encryption algorithm, they also needed a key. This key was kept secret and allowed only the participants in the conversation to decrypt the message. Having a key means that the encryption and decryption algorithms can be open for anyone to inspect. The key appeared as a series of random ones and zeros, each one corresponding to a bit. The total number of bits in a key is known as the key size. For example, a key with a key size of 20 bits might look like this. Alright, now let's sum up the encryption using logic. Message M plus an encryption key, K, processed by the encryption algorithm, E, creates ciphertext, C. Alice's message is now encrypted. Even if an adversary can access the ciphertext, they won't be able to interpret or decipher the message. So far, so good. But how does Bob, the intended recipient, read the message? For that, using our logic statement, Bob the receiver needs a decryption algorithm and a key. To implement this process, we need to understand how to encrypt the message, M. There are two types of algorithms for encrypting messages: symmetric encryption and asymmetric encryption. In symmetric, the same key is used to encrypt and decrypt the data, making it fast and simple but less secure. Asymmetric, also known as public key cryptography, uses two keys, a public key and a private key. What one key can encrypt, the other can decrypt. Symmetric encryption algorithms take as parameters the clear text message and a key. The resulting ciphertext is sent to the receiver, where the original clear text message can be decrypted using the same key the sender used to encrypt the message. There is a wide range of symmetric key algorithms, such as DES, 3DES, AES, IDEA, Cas5, 2FISH, Serpent, Camellia, Blowfish, Kuznetchik, and Safer. Data Encryption Standard, DES, was the first to be adopted. It was developed in the 1970s by IBM with the National Security Agency. DES became a federal standard for shared key encryption from 1973 until 1997, when it was considered cryptographically compromised and deprecated, meaning its use was no longer recommended. The Advanced Encryption Standard, or AES, replaces DES. In all symmetric key algorithms, the sender and the receiver both require knowledge of the selected algorithm and key prior to communication. Symmetric key algorithms therefore assume that both parties securely exchange the key outside the message channel, prior to setting up the encrypted communication. They could meet in person, for example, and exchange the key. This is called a key exchange challenge. Asymmetric encryption, or public key cryptography, does not require a shared key. Instead, both parties generate their own private key and never share it with anyone.